So the moment of inertia of the first rectangular area with respect to the global centroidal axis is that moment of inertia of the first rectangle with respect to the global centroidal axis is the moment of inertia of the first rectangle with its own local centroidal axis. Moment of inertia of the first rectangle with its own local centroidal axis plus area of the first rectangle into the h bar distance square, where the h bar distance is the location of the local centroidal axis with respect to the global centroidal. This distance is h bar distance. So if we can able to find out what is the area, what is the h bar distance, and what is the local centroidal axis, local centroidal moment of inertia, then we can able to find the moment of inertia of the first rectangle with respect to the global centroidal axis. This is the parallel axis theorem. So with the help of this theorem we can say that the moment of inertia of the first rectangle with respect to the global centroidal axis is moment of inertia of the first rectangle with respect to local centroidal axis plus area into h bar square. So if we plug everything into this formula, we can able to say this is this much value, and moment of inertia of the second rectangle with respect to the global centroidal axis, moment of inertia of the third rectangle with respect to the global centroidal axis. So if we can sum up all the three, we can able to say what is the moment of inertia of the entire I section with respect to the centroidal axis x. And similarly for the y axis, if we sum up all the moment of inertia of all the three rectangles with respect to the y axis, the centroidal axis y axis, then we can if we sum up all the three, then we can able to find the moment of inertia of the entire composite area. So but whereas in this case, because it is symmetric about the y axis, the local centroid as well as the global centroid lie in the same axis. The local centroid as well as the global centroid, it lie in the same line. So the h bar distance will be 0 in this case. So moment of inertia about the y axis is again the moment of inertia of the local centroidal axis plus area into h bar square, but whereas in this case, because it is symmetric about the y axis, the h bar distance is 0. Thank you.